Welcome to the lesson on paper recycling. Worldwide, there's about 330 million tons of paper produced every year, which means there's a lot of waste paper in our urban forest available for recycling. Recycling might seem like a new idea to many people, but it's a very old idea to paper makers. As early as 200 BC, the Chinese were using the fiber recycled from old fishing nets to make paper, and paper was made from recycled rags for almost 2,000 years. When you've finished this lesson, you'll be able to identify, as you might expect, paper recycling varies a lot from country to country. However, many countries are very serious about reclaiming these valuable resources. The U.S., for example, has increased paper recycling in recent years so that now 50% of all paper used there is recycled. Some of this recycled fiber is shipped overseas, but recovered fiber still makes up close to 40% of all the fiber used to make paper and paperboard products in the U.S. Every day, paper makers recycle enough paper to fill a 15-mile-long train. And now a new goal has been set to increase recycling to 55% by 2012. The 55% goal represents an increase over today's paper recovery levels by the equivalent of 23 Empire State Buildings annually filled with paper. Paper recycling has good support from the government, consumers, and paper companies. But in the long run, it's economics that drive recycling. In countries that have a ready supply of virgin fiber, that is wood, if recycling doesn't make good business sense, it won't happen. From the papermaker's standpoint, waste paper can be a good fiber source, which is competitive in price to kraft pulp made at the mill and cheaper than purchased virgin pulp. Many mills use recycled fiber to increase their fiber supply to the paper mill instead of building new kraft pulp mill capacity. And smaller recycled paper mills can be located in industrial parks near the urban forest and near the mill's customers. From the standpoint of the consumer, that is you and me, recycling keeps good paper from being thrown into our landfills. Recycling also takes the pressure off of our forests to supply all the fiber we would otherwise need. We have more trees now than we did 70 years ago, and recycling is an integral part of our sustainable forest. Let's review the different types of recycled paper. Recycled paper is classified as either post-consumer or pre-consumer waste. Post-consumer waste is paper which has been converted into a product, served the purpose for which it was intended, and then discarded by the user. A good example of post-consumer waste paper is old newspapers, or ONP. Pre-consumer waste is paper created in a manufacturing or converting operation. An example of pre-consumer waste is box plant trimmings and scrap, sometimes called double-lined kraft, or DLK, which is waste generated in the manufacture of corrugated boxes. For the most part, post-consumer waste has more contaminants and is considered a lower quality grade of recycled fiber. There are a lot of different grades or classifications for recycled papers, but let's look at some of the more common ones. The easiest paper product to recycle is used corrugated boxes. Over 95% of the goods we use daily are shipped in corrugated boxes, and 30% of the paper produced worldwide is used to make corrugated boxes. That's around 100 million metric tons of corrugated boxes produced every year. Many businesses have a compactor that bales old corrugated containers, or OCC, and many municipalities collect OCC from homeowners. In fact, in North America, around 75% of all corrugated boxes are collected, baled, and sold as OCC. No other grade of paper is so widely recycled. What happens to all that OCC? Well, the majority is recycled into other brown grades of paper or paperboard. The most common reuse is to make corrugating medium and linerboard, which are the components glued together to produce corrugated boxes. Let's look at how OCC is processed to become pulp for these grades of paperboard. You might think that when you buy OCC that one bale is pretty much like another, but that's not true. Depending on the supplier and the source that the used boxes were collected from, there may be a wide variation in the level of contamination. OCC from one source may be clean and free of other waste paper and foreign material, while another source may be full of contaminants. What are contaminants? Anything that you don't want in the final product. The stories of bales of OCC containing shoes, guns, money, engine blocks, bowling pins, and entire desks are true, even though hopefully they're not an everyday occurrence. More commonly, the problem contaminants are hot melt glues, waxes, tape adhesives, and other stickies as they're called in the paper mill. So step 1 in the recycling process is to inspect and sort the incoming bales of recycled paper for quality. Remember, the cleaner the incoming waste paper, the easier it is to recycle it into clean new paper. Really bad bales can be rejected, and other bales can be separated based on the suspected level of contaminants. Then the cleanest bales can be mixed with more contaminated ones to keep the level of contaminants under control. Once bales are sorted, they're fed into the pulper so the OCC can be broken up into the individual fibers, that is, to make the OCC into pulp. A conventional pulper looks a lot like a kitchen blender. There's a tub with a rotor in the bottom. Bales are mixed with hot water and the action of the rotor breaks the fibers in the paper apart. Pulpers may be set up to run in batch mode, but most pulpers for OCC are set up to run on a continuous basis. That is, the bales of waste paper are continuously being fed into the pulper along with hot water, and the pulp is being continuously extracted through the bottom of the pulper through a screen plate that's usually located underneath the rotor. Removal of large contaminants is also on a continuous basis through a junk tower, ragger, and detrasher. During the pulping process, it's important to try to keep from breaking the contaminants into small pieces. It's far easier to remove a whole tennis shoe than it is to take out little pieces of rubber, vinyl, and cloth. As you might expect, there are a number of different ways to remove contaminants from the good fiber. Let's quickly go through the operation of this particular system. First, the action of the rotor breaks up the corrugated boxes into a pulp slurry of fibers, and these fibers are continuously being extracted through the screen holes under the rotor. Unfortunately, there are a lot of other things that also get into the pulper, and these are the contaminants that we want to remove. The ragger is an old method to take out contaminants, but it's still an effective first line of defense. The rotation of the material in the pulper forms a spun rope from baling wire, plastic pieces, and other material. The ragger slowly pulls this rope of rejects out of the pulper, and new material continues to collect on the tail that is still in the pulper. As the rope is removed, it's cut into pieces and taken to landfill. A junk tower is a separate vessel behind the pulper. Large, heavy pieces flow into the junk tower, and these can be removed by the grapple hook. Lighter material is taken off the top of the junk tower and sent to the detrasher. The detrasher acts like a separate small pulper to break up the pieces of OCC and separate the fibers from the large pieces of plastic and other trash. This trash is then sent to the reject screen to be dewatered before being rejected from the system. This is a drum pulper. Drum pulpers work at high consistency on a continuous basis. Bales enter one end of the drum and the rotating action lifts the paper and repeatedly drops it. Fibers are separated, but the contaminants are left in large pieces, which make them easier to screen out. As the pulp moves through the drum, it enters the screening zone where dilution water helps flush the fibers through the screen plate openings. Rejects are discharged through the end of the drum intact and fiber-free, so losses are at a minimum. Once the pulp has left the pulper, the pulp slurry is usually pumped through high-consistency centrifugal cleaners to remove larger heavy materials such as staples, rocks, and glass. The stock enters the top of the centrifugal cleaner on an angle tangential to the body of the cleaner. Inside the cleaner, the stock spins around like a cyclone or tornado, and the centrifugal forces push the heavier contaminants to the side of the cleaner. Heavy contaminants work their way to the bottom of the cleaner where they're discharged, and the good fiber exits through the top of the cleaner. Depending on the type of pulper and the final end use for the pulp, the stock must be coarse screened to remove larger contaminants such as any remaining fiber flakes, larger pieces of plastic and wood, and then fine screened to remove smaller contaminants such as stickies and bits of dirt. Modern pressure screens consist of a screen basket with holes or slots and a rotor that keeps the screen holes or slots from plugging. Depending on the application and design, rotors have many different configurations. Both coarse and fine screening is usually done in multiple stages, arranged so that there's a minimum of fiber lost from each system. In coarse screening, there are a number of different styles of screens that can be used. Most screens are centrifugal, meaning that the stock flows from inside the cylinder to the outside. Another type of coarse screen uses the opposite or centripetal flow pattern, where the stock flows from the outside to the inside of the screen cylinder. This type of screen often doubles as a high-density cleaner, which can simplify the process. Coarse screening normally uses holes in the screen baskets to remove the large contaminants. But in order to remove the smaller contaminants, fine screening requires much smaller slots. Fine slotted screens are perhaps the most important step in any OCC system making high-quality stock for linerboard production, where sheet appearance is of primary importance. Screening out contaminants with fine slots is the best method for controlling stickies, a major problem in most OCC processing plants, so a lot of attention needs to be paid to this step in the process. Doing so will result in much better pulp quality and lower overall costs of the operation. Usually arranged in multiple stages, the fine screening operation is designed using low pulse rotors that don't push stickies through the screen plate openings. Modern screens use slots that range in size from 0.15 to 0.20 millimeters or 0.006 to 0.008 inches, so that extremely fine debris is removed efficiently with little loss and good fiber. We discussed high-consistency centrifugal cleaners a minute ago. They remove the larger heavy contaminants with pulp consistency around 4 to 5%. However, the pulp also needs to be cleaned at low consistency to remove smaller contaminants. Low consistency cleaners work at a stock consistency around 1%, and the action inside the cleaners is the same as it is in a high consistency cleaner. That is, the centrifugal action separates the heavy particles such as sand to the outside walls of the cleaner, where they then are discharged through the bottom of the cleaner, while good fiber is discharged through the top of the cleaner. Some cleaners are set up to work in reverse, where the light contaminants such as expanded packing foam that collect in the center core of the cyclone are discharged through the top of the cleaner, with good fiber discharged through the bottom. And some cleaners, such as the one shown, separate both heavy and light contaminants. So low-consistency centrifugal cleaners can be used to remove lightweight contaminants as well as heavyweight contaminants. This is the end of the first lesson on recycling. What we just described is the process by which OCC would be turned into pulp for use in brown grades such as linerboard, corrugating medium, and grocery bags. Note that we did nothing to remove the printing ink that was on the outside of the boxes, and we did nothing to increase the brightness of the